So we're trying something a little different this week. I'm going to try and record what's on your screen, and I'm going to sit down here in the corner and talk to you and try and explain it. There's a lot of things going on this week with tornadoes that are really hard for me to draw. So I thought I'd show you a couple of animations and a couple of video clips and let you see them, with a little better artwork than normal. So for starters, just in general, we're looking at tornadoes. Huge columns of air that are spinning from a cloud all the way down to the ground. Now you'll notice this one is taking place inside a thunderstorm, which is where most tornadoes happen. So our goal is to try and explain to you why tornadoes take place in the first place. So what we're going to see is something in the beginning here called wind shear. Now, wind shear is simply when you have wind at like different elevations going at different speeds and sometimes different directions. Now, wind shear in itself is not a big deal. If I could see it in the atmosphere, which you can't, you would see it happening every single day. It happens all the time. But as you can see, we have slower wind and faster wind. And what it's going to do is it's going to create a wind tunnel. You're going to notice in the screen it's just going to start churning, which again is no big deal because it's going in a horizontal direction. Okay, this is happening up in the atmosphere where you're not going to be able to feel it or see it, but you can see it spinning horizontally. The problem comes in is when you have a thunderstorm, because in a thunderstorm you have a really strong updraft, which can cause this rotation to bend upward. Now, the strongest thunderstorms have something called a mesocyclone going on inside them, which means before this tornado forms, the thunderstorm is already rotating. So these are your most severe thunderstorms. They're called supercells because they have this rotation. So anytime the updraft shoves the wind shear, wind tunnel up towards the storm, if they're going the same direction, it will intensify and you get a tornado going right down to the ground. Now, the only thing I disliked about this animation was it kind of shows the tornado just as big as this mesocyclone, which is not real. The mesocyclone is multiple miles wide, whereas the tornado at its biggest is going to be a mile wide at the base. So it's a little distorted in terms of size, but overall, this looks pretty good. So that, in general, is how we get tornadoes to form.